I'm Cikgu Najiha. So today we are going to explore something that all around us in design, art and even nature, which is polygons. But we are not just going to look at their shapes, but we are going deeper to understand the angles inside of them. By the end of today's lesson, you will not only know how to work with the interior angle, but you will also be able to explain why certain patterns happen in geometry. So are you guys ready? Let's dive in. So before we are going deeper, let's take a look at the what we call the learning objective for our lessons today. So learning objective 1. We must understand the meaning and formation of interior and exterior angles. First, let's understand what we mean by interior and exterior angles. So an interior angle is formed inside a polygon where two sides meet. Imagine standing inside a room at the corner. The space between the two walls is the interior angle. Now, an exterior angle is formed outside the polygon. When you extend one side of the shape and look at the angle between the extension and the next side. So why is this important? Because identifying and differentiating these angles help us analyze and solve many geometric problems, not just in exams, but in real-world applications like engineering and design. Learning objective 2. So next we're going to take a look at how to calculate the sum of interior angles in any polygon. We use this formula. Sum of interior angles, which is n minus 2 multiplied by 118, and we got the sum of the interior angle of the polygon, where n is the number of the sides of the polygon. So let's try it with a pentagon. A pentagon has 5 sides, right? So we calculate using the formula 5 minus 2 multiplied by 118 equal to 540. And we got the answer is 540. Learning objective 3. Now let's think about this. Every time we add a side to a polygon, what happens to the interior angles? Let's start from a triangle. Triangle has 3 sides and its interior angle add up to 118 at one side, and you get a quadrilateral. Now the sum is 360. At another side for a pentagon, it becomes 540. Do you see the pattern? Each time we add a side, the total increased by 118. That's why the formula works, because we are essentially adding a triangle every time. So, this helps us develop reasoning. The number of sides has a direct and linear relationship with the sum of interior angles. The more sides a polygon has, the larger the sum of its interior angle. So to wrap up, today we have discovered how interior angles are formed, learn how to calculate the total interior angles of any polygon, and most importantly, we understood why the formula works. In our next activity, we will prove this formula using paper sheets, and you will see how this theory comes alive. Great work so far, everyone! So class, here's a simple and engaging hands-on activity to help you guys discover and prove the formula for the sum of interior angle of a polygon. So we are going to play one activity which called triangulating polygons. The objective of this activity is to prove the formula for the sum of interior angles of a polygon. So do you guys remember the formula of the interior, how to calculate the interior angles? So the formula is n minus 2 multiplied by 118, and we got the interior angles. So to play this activity, we need a material, which is 1. We need a plain paper. 2. We need a scissor, and we need a marker and ruler. So what we waiting for? Let's go play some activities together. So everyone, let's go to our activity. So as you guys can see, I have drawn and provide a various polygons where I prepare at least 2 different polygons, which is triangle and hexagon. So I have labeled also the what we call the verticals of the polygon with A, B, C, and here A, B, C, D, E, F. So after I have labeled the verticals of the polygon, I choose one vertex and draw diagonals from and from one vertex, I draw diagonals to all non-adjacent vertices. This will divide the polygon into triangles. As you can see here, I have A, B, C, and D here. So as you guys can see, here is the triangle. We have 4 triangles here. 1, 2, 3, and 4 triangles. We will proceed with triangles first. So as you can see, this I cannot divide the polygon, this triangle into another triangle because this is the triangle. So as you guys can remember, the formula of what we call interior angle is like here. And minus with 2 and multiply with 180. So you guys know that the triangle is 118 degrees. As a proof, I will calculate for you guys, okay? So the formula is n minus 2 and multiply by 180 degrees. Okay, n. I have told you guys, what is n? N is the side of the triangle. So here we can calculate one side, 2 sides, and 3 sides. So we just write like this: 3 minus by 2 and multiply by 118. And we got it. So calculate everyone. So what you got? 180, right? So we got 180 degree for triangle. So this is the proof of the degrees of the triangle. So we are going to calculate the interior angle of hexagon. How we can calculate the interior angle of hexagon? So let's go. Okay guys, actually we just need to put the number of the sides of the pentagon into the formula to get the interior angles. So let's try. So so we calculate how many sides that hexagon has. So 1, 2, 3, 4, 5, 6. We have 6 sides of pentagon. So n equal to 6 minus by 2 multiply by 180 degrees, and we got, let me take my calculator first. So we calculate, we got 100, we got 720. So the answer is 720 degrees. But this is not enough. We need a proof. We need a proof of how this hexagon actually we can calculate the interior angles of a hexagon. So here's the proof. As you guys can see, we got 4 triangles here. So we just count the number of triangles formed. 1, 2, 3, 4. 4, and each triangle has an angle sum of 180, right? So we just multiply the number of triangle by 180, and at the last we will compare with the formula with the formula we use here. So the first answer is 720. So we are going to calculate for another formula. So let's go. So guys, let's come closer with me. Okay. Okay. Wait a minute. Wait a minute. Okay guys, so as you guys can see, we have 4 triangles here. So how we want to calculate the interior angles of triangle? So we just calculate it like this. For 1 n equals to triangles equals to 3. 3 minus 2 multiplied by 180. So we got how? We got 118. So right here. Okay. So every triangle has 180 degrees. So we just need to multiply it with 4. Multiply it with 4, and we got 180 multiplied with 4. We got 720. 720 degree. So it's the same, right? So here you guys can see the what we call the different two formula that we can use to calculate the hexagon. Actually, this formula is not only used for hexagon, but you guys can use it with another polygons such as pentagon, octagon. So you guys can try it on your own. So I think that's all for today's class. We will meet again in the next class. See you guys.